there's two different types of special right triangles. There's a 45, 45, 90 and a 30, 60, 90. So the sides of a 30, 60, 90 are, if you have an equilateral triangle, so this triangle is equilateral, and you drop down a perpendicular bisector. If the hypotenuse is 2x, and this bisects, this has to be x. So you have this red triangle that's a 30, 60, 90. So in order to find the long side of the triangle, you do the Pythagorean theorem. So it's x squared plus, we'll call this y squared equals 2x squared. That's going to turn into x squared plus y squared equals 4x squared. Y squared equals 3x squared. Take the square root. Y equals root 3x. Or x root 3. I'm going to write x root 3. So if you're talking about the ratio of the triangle, the sides, the ratio is x to x root 3 to 2x. But we can simplify this as 1, root 3, and 2. Kind of think of it going in order. This is from least to greatest. So 1 is less than root 3. Root 3 is less than 2. So in order to find missing side lengths, you're going to use similar triangles. So here's the first example. I'm going to draw in a 30, 60, 90 that's similar and label the side lengths. So this would be the 60 right here. So the short side is 1, the long side is root 3, and the hypotenuse is 2. So now I can use similar triangles to find what x is. But look how the hypotenuse is twice the short side. So if this is 10, this has to be 5. And if this is 5, this has to be 5 root 3. But I will show it with proportions right now. So I'm going to do 10 is to y as 2 is to root 3. 10 is to y as 2 is to root 3. So it's going to be 2y equals 10 root 3. Divide both sides by 2, so y equals 5 root 3. Okay, the second one over here. Again, I'm going to draw in a 30, 60, 90. So 30, the shortest side is 1, the hypotenuse is 2, and the long side is root 3. So I'm going to use similar triangles again. So I'm going to do 1 is to 2 as 2 is to z. So 1 is to 2 as 2 is to z. So when I cross multiply, I get 4 equals z. So z equals 4 right here. And then to get w, I'm going to do w is to 2 as root 3 is to 1. So w is to 2 as root 3 is to 1. And then I cross multiply. 2 root 3 equals w. So as long as you can draw your similar right triangle that looks the same and you know the side lengths, 1, 2, root 3, you can set up a proportion and solve the other ones. Okay, then this one right here. I'm going to draw in a right triangle. 30, 60, short side is 1, so opposite the 30 is 1. Opposite the 60 is root 3, and the hypotenuse is 2. So, to find this length right here, I'll call this x. I'm going to use the proportion 1 is to root 3 as x is to root 10. So 1 is to root 3 as x is to root 10. and cross multiply. So it's x root 3 equals root 10. So to solve for x, I divide both sides by root 3. And then I kind of ran out of room. I want to rationalize it. I do not want to keep this square root in the denominator. So I have root 10 on the top, so I multiply that by root 3 and the denominator by root 3. So it's 3. Well, 10 root 3, or root 10 root 3 is root 30 over 3. So x is root 30 over 3. And I can use similar triangles, or I can use that. Once I have the short side, the hypotenuse is always twice this. So it would be 2 root 30 over 3. Sometimes once you find one of the sides, if you know the hypotenuse, the short side's always half of this. If you know the short side, the hypotenuse is twice that. So let's do another one right here. So I know this is the short side right here, and this is the hypotenuse. So the short side's always half of this. So I'm going to write the short side as root 11 over 2. The long side is always the short side times the square root of 3. So I'm going to write, this is going to be root 11, root 3 all over 2. So this is root 33 over 2 is my answer.